All right. So I am going to color code. So if you want to use multiple colors, let's do it. Some vocab for you. You guys are all familiar with the coordinate plane. So when we're talking about like angles on a coordinate plane, let's just remind ourselves that this is 0 degrees. This is 90 degrees. This is 180 degrees. This is 270 degrees. And then this would be 360 degrees. So 360 is one full rotation. And then for the purposes of some of the questions I'm going to ask you today, this is quadrant 1. This is quadrant 2, quadrant 3, and quadrant 4. You guys familiar with the quadrants? Okay. It's maybe been a while, but hopefully you're good with your quadrants. So let's talk about an angle. Generally, we start an angle at the vertex that's at the origin. And so then you have this like line here. This is your initial side. So this is going to be our initial side. And when you actually like do the rotation, so you make some kind of, and I'm just going to make up a random one here, but say you rotate like this, and you end up with an angle, and your side ends up over here. This pink side is your terminal side. It's where you end up at the end. So this is your terminal side. Okay, so I want you to be familiar and comfortable with the terms initial side and terminal side and just kind of our coordinate plane and how these angles look on the coordinate plane. We will talk about radians today as well, but let's just focus for now on in degrees, what are these terms? So one of the things I'm going to ask you to do is in example 1, we're going to draw angles in standard position. Meaning that they're going to have that initial side that's just on like the 0 degree. And then we're going to run through whatever angle it needs. This is going to be approximate. So if you would like to use a protractor today, that's fine. But like, honestly, for today, I'm good with you just having a ballpark. If you're in the wrong quadrant, then yes, I will mark you wrong. But ballpark kind of where we're at. You will, so on Go Formative, you'll have a space I just asked you for like the quadrant that the terminal side is in. But then on your homework, I'm checking for 3 angles drawn. So part A here, we have negative 120 degrees. Does anyone know how can you run a negative degree? How could I?
No.
You're getting actually to our next concept, I think, a little bit, but no. So like thinking in terms of direction, how might you reflect a negative?
Yeah.
Yeah, so instead of going the normal counterclockwise way, I'm going to actually go clockwise. So if you think of this is our initial side, and then I'm going to weirdly relabel my degrees. So say this is still 0 degrees, but now let's let this be negative 90 degrees. And this can be negative 180 degrees. We can run backwards. There's nothing that says we can't. So this would be negative 90 and then a little past negative 90. So like there-ish. And again, I'm just approximating. If you want to pull out a protractor, go for it. So what quadrant do I end up in? Yeah, this is quadrant 3. And we would say that this is a negative 120 degrees. Ish, give or take. So the next one is 400 degrees. So now this is positive, so I can run in the normal direction. So I have 0 degrees, 90 degrees, 180 degrees, 270, and then 360 is actually not enough. So I'm going to go past 360. I'll do another, what's 360 plus 90? 450. All right, so 360 plus 90 would be up to 450 up here. So I'm going to still start with this initial side. And now on your work, you do need to reflect like that you've rotated multiple times. So when you draw these angles, I'm going to go one full rotation through. And then how did I draw this? Like up to there. And I will say that that is 400 degrees. And I'm really just eyeballing these, not negative, sorry. So this is 400 degrees. What quadrant did I end up in? Yeah, quadrant 1. So again, on GoFormative, you'll have a spot to like put the quadrants. It's like a multiple choice. So you literally can just click until you get the green bubble if you really want. But I am looking for these pictures at the end in your work. Questions about drawing angles in standard position? Perfect. On to the fun stuff. All right, so I think, Karina, this is sort of what you were getting into, that you are aware that angles have many names sometimes. You can rewrite them as other angles. This is actually called coterminal angles. So coterminal, I should say angles. Coterminal angles are angles whose terminal sides coincide in standard position. So actually on that initial like drawing that I made, we saw those. When I went all the way around, first I started at 0 degrees and then all the way around was 360 degrees. So technically 0 and 360 are coterminal angles because they end in the same spot, even though you did like multiple rotations. So we can find these coterminal angles. And what we're going to do is we're going to find one positive and one negative angle that are coterminal with the given angles. So what you're going to find is on GoFormative, and actually your book gives these coterminal angles between negative 360 and 360 degrees. But technically, there's an infinite number of coterminal angles because you could just keep adding a rotation on, right? And you could say that those are still equal to each other because they are. It's just multiple rotations. But let me show you how the book does it. So what you can do, this first one is negative 45 degrees. So we're going to start by just saying negative 45 degrees. And then we're just going to add a rotation to it. So I'm going to add 360 degrees. Which if you do the math, that it would put you at 315 degrees. So that's one positive coterminal angle for this initial angle. How might I find a negative coterminal angle? Yeah, I can just go the other way with my full rotation. So I'm going to go minus 360 degrees. And so I get negative 405 degrees, which I guess is not between negative 360 and 360, but you get what I'm saying, hopefully. So then my final answer on GoFormative, you would just enter these two answers with commas. So 315 degrees and negative 405 degrees. Now, you do need to include the degree symbol on your GoFormative homework because we are also going to be working with radians, which I haven't talked about yet. But on one of these problems, I do have a radian one because I think you guys can figure it out. So if I give you something in degrees, I want the final answer in degrees. If I give you something in radians, I want the final answer in radians. Some useful GoFormative codes if you are interested. I think these are on the map keyboard too, but you can do / degree. And then if you hit space, it pops up instead of degree. And then when we do our radians, you want / pi. You hit space and it turns into the pi symbol, okay? If you want those. All right, we're going to make one adjustment to our notes here. The negative 100 degrees, it's a fine problem, but it looks just like this. So let's make it more interesting. Let's just change this. I am fully changing the problem. I'm not saying these are equal. So cross it off. Instead, let's say we were given the angle 395 degrees. I want to find a positive and a negative coterminal angle from 395. So technically, you could take this 395 and you could totally add 360 to it, and that would be coterminal. I'm going to subtract, though, because I want something smaller. I want really at least one that's between 0 and 360. I'd like to know one coterminal angle like that. So if you do that, you get 35 degrees. Now, I haven't gotten my negative coterminal angle. What could I do to this 395 to get a negative coterminal angle? Because I already took away 360 and it didn't get me into the negatives. Say that again? Yeah, so you multiply 2, right? So we could say, okay, minus 2 times 360, which yes is 720. And really, if you just think about in terms of rotations, this is saying take away 2 rotations. And that would give me negative 325 degrees. So now I have a positive and I have a negative coterminal angle. I have 35 degrees and negative 325 degrees. Again, you can have lots of different answers. So there's 3 that look like this, and maybe you won't get the right answer right away. But if you've added or subtracted 360 degrees, or for the radian ones, the radian check, you have the right answer. I just have to go through and double check it because I can't have every single correct answer if there's an infinite amount of them, if that makes sense. Okay, so let's talk about the fun stuff. Let's talk about radians. So degrees are, at the end of the day, degrees really are like a unit of measurement, a unit of degree here, or of angle rather. So angles can also be measured in radians. So to define a radian, let's consider a circle with radius r, centered at the origin as shown. So this is our radius r. We can say that 1 radian is the measure of an angle in standard position whose terminal sides intercepts an arc length r. So in our picture, what that looks like is we're saying that 1 rotation here, or not rotation, but it's not a full rotation, 1 radian here, intercepts an arc length. Remember, arc length is like this circumference of just a part of a circle. And this arc length is also r. That would be 1 radian. Okay, so our arc length is r and our radius is r. And that rotation that takes us there is 1 radian. Because the circumference of a circle is 2 pi r, there are 2 pi radians in a full circle. Degree measure and radian measure are therefore related by the equation 360 degrees equals 2 pi radians, or 180 degrees equals pi radians. Generally, we don't write the radian unit. You just, once you see the pi's, you kind of know it's in radians. If you want to write the radian unit, you're welcome to, but it's not necessary. But I do need to see the degree symbol to know which one you're using. So I'm gonna fill out what's called like a unit circle here. I don't know why I made it so tiny, just to make you guys suffer. I think on Wednesday I will give you another one that's huge and blank, and we're gonna fill it out again. So if this is a little overwhelming, don't let it be. But I just want to show you guys this because eventually you will be memorizing this. So let's see it. So what I'm gonna do, I'm gonna start in pink with our degrees. So as a reminder, this is 0 degrees. And let's consider that I cut this into 8 pieces. So I'm going to cut each quadrant in half to start. Done that in purple, but oh well. So if I cut this in half, I know this is 90 degrees. Just let me be consistent when I'm putting the numbers. This is 90. This is 180. This is 270. And then this would be, again, be 360. If we're looking at just like an eighth of this, this goes by 45. So this is 45 degrees. This would be 135 degrees. And that would be 180 plus another 45 plus another 45 would be 225. And then plus another 25 would be 270. And then plus 25 again would be 315. So that's degrees, adding 45 degrees each time. I'm going to switch back and forth between radians and degrees twice here. So now I'm going to do the radians in blue. What that definition above told us was that this is either 0 radians. This is pi radians. So if you think about 90 degrees as half of 0 to 180, so 90 is half of 180, half of pi would be pi over 2. Okay, that's 90 degrees. These are equivalent equivalent measurements, just in different units. And then 270 would be 3 pi over 2, because essentially you're just adding pi over 2 each time. This would be 0 pi over 2, 2 pi over 2, which reduces to pi, and 3 pi over 2, and then 4 pi over 2, which reduces to 2 pi. So that's going around the circle and just adding pi over 2. Now let's go around the circle and add like a fourth each time, so pi over 4. So 45 degrees corresponds with pi over 4. This would be 2 pi over 4, which is pi over 2. This would be 3 pi over 2. I'm sorry, over 4, not over 2. 3 pi over 4, because we're adding fourths. This would be 4 pi over 4, which reduces to pi. This would be 5 pi over 2. This would be 6 pi over 2, which reduces to 3 pi over 2. And then this would be 7 pi. I keep saying over 2. It's over 4. Because it reduces each time. I'm just stuck in my own head. Sorry. All right, so that's adding a fourth each time in both degrees and in radians. The other common way that you see degrees is adding a third each time, or 30 degrees. So add 2 more marks here. This is 30 degrees. Add another 30 degrees, you're at 60 degrees. Add another 30, you'd be at 90. Add another 30, and I'm totally going to run out of room here. This is 120. I will give you guys a bigger one on Wednesday. I don't know what I was thinking. Add another 30, you're at 150. Add another 30, you'd be at 180. 180 plus 30 gives us 210. 210 plus 30 will give us 240. 240 plus 30 gives us our 270. 270 plus 30 is 300. 300 plus 30 would be 330. So that's going around and adding 30 in our degrees each time. Okay, so these are the weirder looking radians. Now we're going to add a sixth of a radian each time. So this would be pi over 6. This would end up being 2 pi over 6, which reduces to pi over 3. And then you'd add another pi over 6. We end up with 2 pi over 3. I skipped from the pi over 2. Sorry. Be pi over 6, 2 pi over 6, 3 pi over 6, which would be pi over 2, 4 pi over 6, which would be 2 pi over 3. 5 pi over 6 will be our 150. 6 pi over 6 would end up just being pi. 7 pi over 6 will be our 210. 8 pi over 6 will reduce to 4 pi over 3. If we didn't have to reduce, this would be a lot easier. And then it would be, let's see, 7, 8 pi, 9 pi over 6 would be 3 pi over 2. And then we end up with 10 pi over 6 ends up being 5 pi over 3. And then we have an 11 pi over 6, which does not reduce. And then finally, 12 pi over 6 would reduce to 2 pi. Okay, so we just inched our way around this circle. We will do it again if you're like, what the heck? We'll do it again on Wednesday. It's not super important for today. I just want you guys to see it because we're going to memorize this with actually more stuff in it. Many math students have done it before you. I have done it numerous times because I forget it every single time. So it'll last with you for a couple weeks and then you'll rememorize it a little faster next time. I think I even had a friend who tattooed it on themselves because they were sick of memorizing it. Which, yeah, I mean, I think at that level it didn't matter anymore because we were like upper level math. We were like, who cares? But yeah. Okay, so how you're going to deal with this today is really just a conversion. You guys remember in IPS converting between like units? The idea is like, okay, so say you had like inches over feet and you were given something in feet, right? You would just multiply by inches over feet because the feet would cancel out. If you were given something in inches, you would multiply by feet over inches because the inches would cancel out. This is actually the same. If you're given something in a degree, you would multiply pi radians over 180 because the degrees will cancel out. If you're given something in a radian and you want a degree, you would multiply by 180 degrees over pi because the pi will cancel out. And I say pi a little loosely, that's our radians. It is also the number pi, but you'll leave it as a pi. So let's see what this looks like. So example 3, we're just going to convert between degrees and radians. So part A, we are in degrees. So our conversion is 180 over pi or pi over 180. In this case, since we already have the degrees, we're going to do pi over 180 degrees. Now, a note of caution here. I actually don't want you to multiply out the pi for these ones. I will have you multiply out the pi for example 4. But in these ones, really, all you're going to do in your calculator is you're going to type 125 divided by 180. Hit enter, you get this nasty decimal. You will convert it into a fraction, however your calculator does that, or do it by hand. So you end up with 25 pi, just throw the pi back on there, over 36. If you have a cool calculator, it will do it for you. I think this one might even do it for me. Let's see, 125 times pi over 180. This might do it. No, it doesn't even. So you want to leave it as a fraction and just have the pi there because that's my indication that this is in radians. Part B, I have negative pi over 12. So now I want to put it in degrees. So I'd multiply it by 180 degrees over pi. And now again, don't type the pi into your calculator. Just remember a pi over a pi will cancel. So really you're doing 180 divided by negative 12. And so you end up with negative 15 degrees. What do we think of converting? Easy, right? You just don't actually put the pi in for converting ones. We will put in the pi for this next one. Okay, last thing we're going to talk about. So since we're dealing with radians, let's talk about arc lengths and areas of a sector and what the heck a sector is. So a sector is a region of a circle that is bounded by 2 radii and an arc of the circle. So think like a piece of pizza. And the central angle is the angle formed by the 2 radii. So this isn't necessarily like where you have like the x-axis, that's your 0 degrees. It's just a central angle kind of anywhere. And then the book gives us these 2 formulas, which are frankly like a little useless in terms of this context. They don't give like enough information. Like what it is r is your radius, and then theta is this central angle in radians. But how you actually apply this is like different. So if you're given something in degrees, the formula you actually want to use is going to be that your arc length S is equal to 2 pi times R times theta over 360. Again, this is if you're in degrees, because that theta over 360 is going to give you like the proportion that your sector is of this full circle. This area formula is like nuts to me because the 1/2 is totally whatever. So the area formula you really need is going to be that theta over 360, because again, that's going to give you like the portion of your circle. So like in this case, this looks like maybe it's like a 1/5. Theta over 360 would maybe end up being a 1/5 because that's the portion of your circle I'm interested in. And then it's just times the normal area of a circle, which is pi r squared. So example 4, we're going to find 2 things. We're going to find the arc length and the area. So let's start by finding our arc length.
Wait, I'm just curious.
Yes.
What is the first one on it that they gave us? Should we just not use those?
So it's not that it's wrong, but like I did it with second hour. R is your radius, and then this theta central angle in radians, you end up having to like remember to convert. And so that ends up being this whole 2 pi times theta over 360.
Okay.
Part.
So like that would be
So it's not wrong, it's just, it doesn't give us enough information.
Okay.
If you're already given radians, I think you can then just multiply your radius and your radians and you're done.
Okay.
But the problem I give you in the book and the problem in the notes, I give you an angle in degrees.
So if it's in radians, that one was fine.
I think so, yeah, I have to double check that, but I'm like 99% sure.
Okay. Thank you.
So our arc length here, when I fill this in, I'm finding the arc length of an area of a sector with radius 5 centimeters and central angle 45 degrees. So my S is going to be equal to 2 pi to take care of this radians business times my radius, which is 5, times 45 degrees over 360. This is going to give me the proportion of my slice of circle. So this is the proportion my sector takes up of the full circle. So just to reduce to see what we get here, you end up with 10 pi times, this ends up being 1/8 of the circle. So basically my circle is cut into eighths and I have 1/8. And that's from the 45 over 360. So my final answer is that my sector is equal to 5 pi over 4 centimeters, or because in Go Formative, I actually want the pi to be multiplied out. It'd be 5 pi divided by 4. So, or 3.93 centimeters, we'll say. On your Go Formative, just the last 2 questions, you will multiply the pi in. All right, now my area formula. For my area formula, I'm just going to plug in that my area is equal to pi times my radius squared. Now, it would be this 45 over 360, but I already know that it's 1/8 of the circle. So you can just go ahead and multiply it by 1/8. And I end up getting that my area is 25 pi over 8 centimeters squared, or how Go Formative will want it, 25 times pi divided by 8, 9.817 centimeters squared. And I tell you what to round to on Go Formative. I do want units. Area is a 2-dimensional unit, so it's squared. An arc length is a 1-dimensional unit because it's technically a line, so it's not squared. Did I round by inconsistent things? I did.
Oh, no.
3.93. I did round at this. If I'm rounding consistently, it should be 0.82, but whatever. So your homework is 12 problems. If you have any questions, let me know, but I think they're pretty straightforward.